Hey, this is Dario Tranchitella from Classics Labs, the creators of Kamaji, and in this video we are going to see how to install Kamaji prior a brief introduction of what is Kamaji. So essentially Kamaji is an open source project. It's an operator that can be installed in a management cluster that is orchestrating a fleet of control planes. So essentially the control planes of a Kubernetes cluster are treated like an application in a management cluster, and these control planes can be used by real worker nodes or virtual worker nodes. It really depends on your use case, and it's adopting the hosted control plane approach. So essentially the control plane is not dedicated to virtual machines, but rather is running as pods in this management cluster. In this video we are going to see how to install Kamaji on Kind, mostly for learning purposes or to give a try to Kamaji, and I'm going to do that by running Kind. So if you would like to install Kind, you can install that from Kubernetes 6 Kind GitHub organization, and right now it's already installed for me. So the first thing that we have to do is to create a Kind cluster. So Kind create cluster, name Kamaji, and now we have to wait. Great, the cluster has been created. Keep in mind that Kamaji has some prerequisites, some dependencies. And the first one is about cert manager. So what I have to do is to add the Helm repository. So Helm repo add Vietnamese. Let me check if I have it in my history. It doesn't. So HTTPS charts Vietnamese com Vietnamese. It already exists. That's great. So what I have to do is to Helm repo update, just to be sure that I have everything in place. Now what I can do is to install cert manager using the Vietnamese Helm repository. So Helm upgrade install cert manager, Vietnamese cert manager, namespace cert manager system, create namespace, set install CRD is true. Okay, cert manager is being installed, and we can check if everything is running. So kubectl get pods in all namespaces, watch, and let's wait a few seconds just to be sure that everything is up and running. Also, a second prerequisite for Kamaji is to have a storage provider. Right now I'm running with Kind, so I have a local path provisioner, but it really depends according to your mileage. So you can have the EBS, another CSI. Keep in mind that since we are running control planes, it means that we are running also etcd, so we have to persist our data. Okay. Once we have cert manager, what we can do is to install also metal LB. Why that? Because the control planes can be exposed by cluster IP, not port, but since we would like to do something really interesting, it would be great having metal LB to create virtual IPs for our control planes. So I'm going to install the metal LB manifest with kubectl apply, and now again I need to wait a few seconds just to be sure that the metal LB images are downloaded and everything is in place. That's perfect, because now what we have to do is to create a IP address pool that is required for getting real IPs. So the first thing is that since I'm running on kind, I need to extract the gateway IP of the network kind I'm running on. Then also this network IP must be a bit modified, and finally I can copy the substitution, which is going to create the kind IP pool and also the layer 2 advertisement. So everything has been created, so that's great. And finally, we can install Kamaji. So the first thing is that we need to add the Kamaji, the classics Helm repository. So Helm repo add classics GitHub IO charts. It has been already added, so just for the sake of security, for being secure that we download everything, Helm repo update, everything is there. That's great. So now what we can do is to install using Helm. So Helm upgrade install Kamaji classics Kamaji. There is a typo. Namespace Kamaji system, create namespace, resources equals to null. And now we have to wait a few seconds because we are going to have a lot of magic happening behind curtains. And I can show you what's going to happen. So essentially, we are creating a job which is going to create the etcd certificates. So if we take a look to the diagram that we see here, the control planes are stateless components and they need to connect to an etcd. So when you install Kamaji, a default data store is going to be created. So we are pulling the images here to generate some certificates required by etcd. The certificates have been created. Now we can create the etcd instances, and we are also creating some persistent volume. That's the local path provisioner. Kamaji is entering in the running state, and in the meanwhile we are waiting for the free instances of etcd. That's great. Everything has been installed, and we can check that because if we should kubectl get crds and we grab by Kamaji, you see here that we have the data store and the tenant control plane is one. So it means that what we can do is to install a sample tenant control plane. So kubectl apply, and I'm using one of the examples that you can retrieve from the repository. So in config, in samples, you see here there are plenty of them. I'm just using this one, tenant control plane. So when I'm playing that, you will notice that the control plane is going to be created. So a control plane endpoint, thanks to MetalB, has been provisioned, a kubeconfig has been created, and now we need to wait for the pods for being up and running. In fact, what's happening? You see here that we have the control plane with all the API server, control manager, and scheduler. And once we have all the pods up and running, our control plane can be considered ready to serve traffic. in less than a minute, we had a fully conformant CNCF cluster, Kubernetes cluster, up and running. -K, and here we are. Of course, what we can do is to download the kubeconfig. This is my kubeconfig. I can put here Kamaji. And take a look here. So we are running 126. If I issue export kubeconfig in the tmp Kamaji kubectl version, you will notice that we have 126.0. And furthermore, since we have hosted control plane, so it means that we don't have proper virtual machines for the control plane. If I issue kubectl get nodes, I don't have any node. Of course, there are plenty of other stuff to do, but this was just a first video trying to show how can you create terminal control planes and how you can install Kamaji in a glimpse. So thank you for watching, and stay tuned for the next video. Bye.